Good. Let me give it a second. Let's people in. All right. Good afternoon, everyone. Thank you for joining us today for this NatureServe webinar. While people are joining, we're just going to pop a little poll up on the screen so you can provide us with a little bit more information about yourself and what you're interested in hearing from NatureServe. So Nicole, can you pop that up for folks? There we go. All right. So if you don't mind, just share a little bit of information. I am Regan Smythe, NatureServe's Vice President for Conservation Science. I'm joined here today by Max Tarjan, our Ecological Modeling Program Manager, and Christopher Tracy, our Director of Spatial Analysis. And we will be sharing with you information about NatureServe species habitat modeling, NatureServe species habitat models, the Map of Biodiversity Importance, and other derived products. Little bit of housekeeping before we start. There is a question and answer button down at the bottom. If you could use that for any questions for us, there's a lot of people on the call. We will do our best as we go along to answer some of that information within the Q&A feature. Feel free to upvote other people's questions as well, and we'll have a bit of time at the end to address hopefully at least a number of those questions. There's also a chat feature which we might be asking you to use at various points of the webinar. And with that, I think we should go ahead and get started. I'm going to end that poll. Thanks for all of you who provided feedback. 5 seconds to submit your answer. All right, I'm pulling that down. Appreciate it. Okay, Max, can you go to the first slide, please? So we at NatureServe are really excited to be talking to you today about our update of the Map of Biodiversity Importance and a set of tools that we've developed for making more of the information that goes into that map available to you. The Map of Biodiversity Importance brings together from data from across the NatureServe network to identify those places in the nation that are most important to protect if we're going to stem the species extinction crisis. The image that you're looking at up on the screen now is from a New York Times article from when we first released MoBI, as we call it. Today, we're able to share an updated version of that map that's also available at finer resolution. Looking at what's up on your screen, I think you see a pretty intriguing, informative picture. One of the things I hope you can also take away from this webinar today is an understanding of that what's represented there is also a pretty incredible effort. This map synthesizes 50 years of data collected by really an army of dedicated biologists from across the 50 states, well, 48 states, it's lower 48. It brings together information that NatureServe works really hard to curate about what species is at risk. It brings together field data and museum specimens and citizen science data on where our nation's rare species occur. And it uses pretty advanced computer modeling and AI to produce a product or really a set of products that can drive conservation of biodiversity at a really critical moment when species are going extinct at unprecedented rates. Today, we'll be telling you the story of this map and the underlying data. We'll be sharing some of the way our partners, including many of the people on this call, are using that information on the ground to drive science-based conservation forward. And we're going to provide information on the tools we've built to help you access the underlying data to support your own conservation efforts. Next slide. So specifically, I'll start by providing a little bit of background on NatureServe and the unique role we play in bringing together data on North American biodiversity. I'll then hand it over to Chris, who's going to be discussing the update of the MoBI maps. Max Tarjan will then take over to share more information about the underlying models and how you can access that. as well as some information on where we're headed next, including work related to climate shift models, which is pretty interesting. We have a few different applications to share of how these data are being used on the ground, and then I'll wrap up with just a review of how to get access and use this information in your own work. So that's the plan. Before we get into all of that, as I said, I want to introduce you all to NatureServe and welcome everyone. There's many of you on this call who have worked with us for many decades, and there's others who are really learning about us for the first time. 2024 marks our 50th anniversary guiding biodiversity conservation and stewardship using the power of science and data and technology. The work that we're presenting on in this webinar, I think, really demonstrates why NatureServe is recognized as a really authoritative source of data for threatened and endangered species in the United States. Our network is the asset that makes NatureServe really special and unique, and it makes products like the Map of Biodiversity Importance possible to develop. 50 years ago, we were founded as the world's first biodiversity information network. Today, we have more than 60 network partners throughout the US and Canada that are staffed with local experts. We design, by design, we track all species. So vertebrates and invertebrates, plants, fungi. We are concerned with biodiversity writ large. At NatureServe, we also go beyond species to identify and classify and assess ecosystems. And together, our databases hold data on more than 100,000 species and ecosystems with more than 1.3 million map locations. A really tremendous resource of information on what's going on with species and ecosystems in North America. I mentioned in the last slide that we track species, but what does that actually mean? Fundamentally, we answer 3 questions: what's out there, where is it found, and how is it doing? Today, we're going to mostly be focused on that where is it question. But the work that NatureServe does to maintain up-to-date taxonomy and the work we do to identify which species are at risk is also really integral to all of the products we're going to be speaking about. When Chris talks a little bit later about what changed between the 2020 version of the Map of Biodiversity Importance and the 2024 version, that work on taxonomy and conservation status, why it's so important is going to be apparent. Speaking of that where it is question, because so much of this webinar is focused on how we answer that, I want to take just a minute to talk a little bit more about where our core information on species locations come from. I talked about NatureServe as a network. Our distribution data starts with a rich set of occurrence data collected and maintained by our network partners. This map is showing the hundreds of thousands of locations that have been delineated where populations of species of conservation interest have been documented and vetted. And this is the hard work of natural heritage programs and other NatureServe network programs on the ground. This next slide shows a bit on how that information comes together. Max, can you go ahead one? Oh, there we go. So that data from our network are shared with NatureServe through a data exchange process. So network programs share their local data on species status and occurrence with NatureServe, and NatureServe brings that all together to generate multi-jurisdictional knowledge on species characteristics, on conservation status, on distribution. We share what we call that global information back to our network partners who use it in their work within their states to have impact on the ground. And then we also develop these knowledge products that support the rest of the conservation community, really anyone who works across jurisdictions who needs good data on species and ecosystems. The information we provide in those knowledge products, that's coming out of those blue arrows on the sides there. It includes the species and ecosystem profiles we host on NatureServe Explorer. It includes spatial data on species distributions, which we'll be talking a lot about, that we provide through NatureServe Explorer Pro. It includes our conservation status assessments, and it includes various applied products, including the focus of our conversation today, the Map of Biodiversity Importance. So now that we've made it there, I'm going to hand it over to Chris to talk a little bit more about the MoBI maps.
All right, thanks, Regan, and hello, everyone. So today, as Regan mentioned, I'm going to be focusing on one of our really signature information products, the Map of Biodiversity Importance. We first released this product back in 2020. We published an article in Ecological Applications. You can see the link to that in the lower left there. And also, as mentioned already, it's also been featured in the New York Times, as well as many other publications and resources. The darker red areas on this map indicate where there's these greater concentrations of imperiled or at-risk biodiversity across the country. You can see that this is not distributed evenly across the U.S., but really highlighted in certain areas. But really, almost everywhere has something important. Right, Max, can you advance the slide? Right, yeah. So we see MoBI as the synthesis of NatureServe network data on location and concentration status of U.S. species. This has been supported over the years by, well, most notably the NatureServe network, all their great field data that went in to this map, as well as Esri, TNC, Microsoft, and the Hewlett Foundation all had a hand in helping create this product and keep it maintained. We recently released a new version, 2024, a couple months ago, and over the next few slides, I'm going to walk you through how we developed this, what changed, and how this can be used to inform conservation. Next slide, Max. Right, so MoBI starts with species habitat models. And these are models that we create. We've been doing this at least at scale for a little over 5 or 6 years now, but we really start with this occurrence data. And we combine this with environmental predictors. We feed this into a modeling engine using cutting edge machine learning techniques to go and create these species habitat models, which you can see on the right here as continuous and categorical model products. We also go and take this information, we try to get this information out to people for expert review and revision of these models over time, and hopefully even have field validation. And this is a continual cycle of model creation, revision, and then delivery again to go and try to create the best view of what we think a species distribution is. Right, next slide, Max. Right, along with these models, we think of these models as just more than the spatial data. We do provide detailed metadata. This metadata includes the review and revision history for all the models, and we also calculate these confidence metrics. Here's a image you can see of this on the right here, which the confidence can range from low to high. And each of these confidence levels, we go and we recommend different uses that this model can be used for based on its performance, both in a qualitative and a quantitative view of model performance. All right, next slide. All right, to go and create MoBI, we basically stacked up all these models. Currently, we have nearly 2,500 models that appear in MoBI. And through just a lot of pretty heavy-duty GIS processing, we go and we stack all these models up. So at a single pixel, you can see that there might be many, one to many. I think the maximum number right now is 34 species that co-occur at the same pixel. And then we calculate a set of different views of MoBI, including species richness, something we call range size rarity, and protection weighted range size rarity. I'll get into each of these in subsequent slides. But MoBI is pretty much a stacking exercise. This is the 2024 map. Darker red areas on this map show greater concentrations of at-risk species. And next slide. Next. So what's included? So currently MoBI includes all globally critically imperiled to G1 and imperiled G2 vertebrates, freshwater mussels, crayfish, butterflies, skippers, bees, including bumblebees, and now solitary bees, as well as vascular plants, and also federally listed and threatened endangered species in the same taxonomic group, but only ones that are listed at the full species level. The 2024 edition of MoBI includes 2,493 total species. This is up from 2,216 in MoBI 2020. Yeah, but This map has changed a lot since 2020. In the original map, we dropped 170 species and we added nearly 450 species. A lot of this is due to changes in rank, changes in status, but also this map has some other significant changes for 2024. One is that it's now released at 330 meter resolution, which is an increase in resolution from the 990 meter that version that the 2020 map was released in. And then something I'm really excited about here is that we rebuilt the process for MoBI. So now we can go and pretty easily release updates in a very streamlined and efficient manner. We're hoping to release annual updates of MoBI, but it also allows us to go and create customized versions of MoBI. So like a hotspot map for all forest-associated species are all species that might be included in a particular state's wildlife action plan. And we're really excited about this possibility to go and deliver custom products. And Max will talk a little bit more about that later. All right, next slide. So zooming into the Western US, just for clarity here, the three different types of maps we include within the map of biodiversity importance. The first is species richness. This is just that really simple stacking of species, how many species overlap in a particular cell. You can see that this range, at least in the Western US, this ranges from 1 to 27. And we have this available, we have maps like this, and actually all these MoBI products are available for all species, vertebrates, the freshwater invertebrates, so the freshwater mussels, and fish, pollinators, and then plants. So there's really a set of 15 total maps that make up the MoBI product. All right, next slide. Thanks. The second type of map we release is what we call the summed range size rarity map. And what this map shows is it's similar to richness, but we weight it by the range size of each species. So species with fewer conservation opportunities, their range is smaller, count more in the map. And you can see that this really is a change from the previous map, where in the previous map, you only saw like California and Arizona being really bright red on the map. This shows where these important range restricted species are throughout the Western US. And it's interesting. This is the one that we really recommend for using. We also include one called protection weighted range size rarity. And this is a modification of range size rarity that's weighted by the amount of each species range that is currently protected, listed as GAP 1 or GAP 2 in PAD US. Next slide. Thanks. And then we also have the areas of unprotected biodiversity importance. This is really just a simplified version of the protection weighted range size rarity map, which is the top tier of the most areas that are most in need of protection across the US, represented in red, and you can see the areas that are protected in green. They could be great targets for land protection efforts. This is this comparison of the areas of unprotected biodiversity importance between 2020 and 24. You can see areas in pink were included in both. Areas that were dropped are in yellow, and areas that were added in 2024 are red. This has to do with a variety of different factors. Some of those taxonomic or conservation status updates, where we may add or lose a particular species. The addition of additional taxa like the solitary bees. The improved resolution, some of the areas that we lost, it just the models are more precise now, so there's a little bit less area represented, and then also additional like the upgrade to the PAD US 4.0 from the previous version, where there's newly protected lands added into here. Right, next slide, Max. Right, just getting into some of these changes that we have here. These three species really illustrate that change. Each of these species was not included in the 2020 version of the Map of Biodiversity Importance, but they're in this edition. 5 years ago, when we first started thinking about that, none of these species, we didn't realize any of these species needed our attention. The salamander on the left wasn't described until 2021. The bumblebee and cactus were newly identified as imperiled just within the past few years. So this really illustrates that our understanding of biodiversity is constantly changing. And the MoBI 2024 species list is about 20% different than the original MoBI list due to these types of changes. So this is really highlighting the important work that the NatureServe and NatureServe network does to go and keep our information current. So just putting in a little plug there that we need support to keep this information up to date. Next slide. All right, looking at the MoBI 2020 map here. There's lots of interesting things. We saw that California, parts of the Southwest, the Southern Appalachians were all really important places. We also saw some very detailed areas like the Ouachita Mountains, plants in the desert Southwest, and the Lake Wales Ridge in Florida as being really important biodiversity hotspots. And the 2024 update is really similar to this at these broad scales, but in many areas we are picking up some new areas, we're getting refined areas, but then also this resolution change. And Max, you can click the next slide. This will transition to the 2024 version. You can see how much more precise the new map is, and it's really targeting the geographic features that are really driving these patterns of biodiversity and providing very detailed information that can be used for local, for fairly local conservation planning. Right, next slide. Right, applications of MoBI include all of these things that we've learned about, things that we've seen, things that we've done. We are and these range from conservation prioritizations for inputting into wildlife action plans, sustainability reporting for corporations and other businesses, land trust outreach. If you guys have used MoBI for anything, please let us know in the chat or the Q&A or send us an email. We're really interested in learning how this is being used and trying to improve the product. All right, and just to move into one example of these applications, this is some work that we're currently doing in the world of corporate sustainability reporting. Here, one thing we are recently learning how to do is to go and use MoBI on the range size rarity map to as a measure of species extinction risk within a geography. So you can see here that in this graph that we have different sites, and we can compare this to each other or to the ecoregional or national context to see what areas have the most extinction risk and what may need conservation attention. And next slide, Max, over here. We can also go beyond MoBI. So MoBI is this aggregation of species habitat models. We can take this and we can go and dig deeper, look at the models individually behind this. This is very similar data showing the number of pollinator species within a focal area. We can gain an understanding of which ones occur within the focal area or outside the focal area, and thus go and help figure out what the conservation targets are in a region. So I'm going to turn this presentation over to Max now, and she can talk more about the availability and access of these habitat models.
Thank you, Chris. Hello, everyone. In the process of created MoBI and other ongoing projects, NatureServe created an expansive library of habitat models for imperiled species. We wanted to expose this information about the models to potential model users so people can evaluate what models are available and what we're working on. To meet this need, we created a model dashboard. The model dashboard provides non-spatial information about habitat models, and it then links to spatial data that's hosted on other platforms. What can you use the model dashboard for? It's designed to answer questions like this. Which ESA listed species have habitat models available for California, Oregon, and Washington? Which precise habitat models are already available to me as a federal government employee? As a taxonomic expert, which of the habitat models would benefit from my expert review? Is a habitat model available for gopher frog? What is its habitat protection status? I'm going to switch over to a live demo of the dashboard to show some of the features. So this is the species habitat model dashboard. There are a few features to key in on. Along the top, we have various filters by species characteristics. So you can select certain taxonomic groups if you're interested in seeing what models are available for a given group. You can filter by G rank, ESA status, SGCN status, whether it is or is not an SGCN. You can also filter based on the subnations where the species occurs. Those are the filters for species characteristics. There's also a panel that you can expand on the left, which allows you to filter by different model characteristics. So you can look for models that were created in a certain date range. You can look at model status. So we have in the dashboard models that are in development, that are under review, models that are published and immediately available to folks, and also external models are identified there as well. You can also look at what organizations have provided review for models, associated projects, and also look at what model ranks you are looking for. So when you apply these filters, it applies them to this table on the right-hand side. So for example, I can look for all models in California, and I can see that there are 827 models best available in California. I can then use this download button to download that table to see the models that are available based on those filters. There's also a metadata option here that describes the different fields that are in the download. One that I want to point out is this definition. So the default view that you'll see are what we are currently calling best available models. And I just want to explain what that means. These are only models that are developed for the full range of the species within the conterminous United States. They are then ranked based on the publishing status, where it's preferred to have models that are published and available immediately. They're also ranked by model creation date, where more recent models are more likely to be preferred and best available. And they're also sorted by the location use class, where there's a preference for models that show year-round habitat. So that's what we mean by best available model. It does not require that NatureServe is the author of models, and we have models in this dashboard that are largely created by NatureServe because of the Map of Biodiversity Importance, but also models by some of the network programs and some external models. And we're hoping to expand that to offer an avenue to find what the best available information is for a given species. So you can see the summary view. There's also a way to search for models for particular species. So I can look at this drop down of species and find, for example, I'm going to look up the golden-cheeked warbler. Select a species. If there's a model available for the species or planned, it will appear in this drop down. There is some species characteristics. So this links to the Explorer Pro or Explorer description of the species directly. So you can find out more about the species itself. And then you can see a list of all of the models that are available for the species that are within the dashboard. So the best available model is listed first, and this is a 2019 model, and there's some information about the model confidence. I can also see that this model is published, so it's accessible by Explorer Pro. And then there's also a second model here as well, and I can see some of the details about that. In this tab, we have intersected all of the best available models with the protected areas database, the PAD-US dataset, to show what portion of this predicted habitat is protected, is multiple use, or falls outside of the PAD-US dataset. So that's this summary chart that you see here. You can see the acreage of predicted habitat, which is in the high probability habitat or medium probability habitat categories. That falls in protected areas, how much falls into multiple use. And then in the case of this species, quite a lot of the habitat is outside of the PAD-US dataset. So that is identified as unknown. Likely a lot of that is unprotected, but it was termed unknown in this case. The other piece I'd like to point out is because we've done these spatial intersections with PAD-US, for authorized users where this is controlled through your Explorer Pro account, there is this additional tab on the dashboard where you can use your Explorer Pro credentials to log in, which I'm going to do now. And that brings up a more detailed view of this spatial overlay with the PAD-US dataset. So I can look at for a given species, which again appears in a dropdown. I can look at the gap status for all of the habitat. And then I can also look at the habitat by agency. So in the case of this daisy, US Forest Service has over 76% of the habitat is falling within Forest Service managed lands. And again, this is available for all best available models. So it's over 2,500 species that have this information available. Also on the dashboard, there's a help tab that gives tips on how to use the dashboard, also information about how to access data, and a feedback form if you encounter anything on the dashboard that you'd like to give feedback on. I'm now going to switch over. So this is non-spatial data, and that leads to the question of how do I access spatial data? So for species that have a published best available model, you can use an Explorer Pro link to go to NatureServe Explorer Pro to see the spatial data for the species. So NatureServe Explorer Pro is our way of providing interactive maps and place-based reporting. It allows you to explore where at-risk species have been documented, including through element occurrence and observation data. And it also allows you to access species habitat models at resolutions allowed by data providers. So I'm gonna just adjust some of the layers here. I can see quite a few layers, but I'm gonna pull up just the relevant ones. All right. So I'm going to start with what you see as a licensed user on Explorer Pro. So this is a species habitat model for golden-cheeked warbler. You can see the dark purple is high probability habitat, the medium purple is medium probability habitat, and then the lightest purple is low probability habitat. Those thresholds are designated by our expert model reviewers. So you can see precise, this is 30-meter resolution model for licensed users. If you are in here in your licensed account, you can also open details about this model and see what the model confidence is and what the source is. In this case, it is a NatureServe generated model. And open up a standardized model metadata PDF that gives information about the model and what data went into it and history on the review information. Now we've just released, and I'm very excited that folks who don't have a licensed data set can still see model data, and it is generalized to the hexagon framework. So in the same way that we generalized element occurrence data to obscure data for sensitive species, the habitat models are also available at this more coarse spatial resolution. So the way that these are generalized is that the highest habitat probability that's predicted in any hexagon is what symbolizes the hexagon. So in this case, these dark purple areas, it means that there's some 30-meter pixel that has high probability habitat in those areas. But this is available to anyone who signs up with a NatureServe Explorer Pro account. I'm going to switch back over. And I've already showed you these features. One other thing I want to highlight about NatureServe Explorer Pro is that it allows a user to draw or select an area and return a report listing species of conservation interest that are documented in and around the area. Right now, the tool will also tell you how many of those species have habitat models in the area. So in this case, there are 2 species that have habitat models in the area, and let you look through the models that are available and link to the spatial data. We are actively working on more fully integrating the model data into these biodiversity reports. In coming weeks, predicted species will be added to the species list for all of the almost 500 models we have published to Pro. This information will appear in reports for both the public and licensed users. So we've taken some big steps towards creating a library of habitat models for imperiled species and in providing access to those models, but we have a ways to go to get the best available information into the hands of decision makers. In the near future, we plan to expand and improve NatureServe's library of habitat models, and also to provide the model standards and infrastructure that will allow model users to find and access models that are developed outside of NatureServe. We're expanding our offerings of multi-species data products, and we're starting a project to create climate envelope models. So first, we can improve the model library and access to it by focusing our efforts on reviewing and publishing models that we've already created. As you can see from this plot, we have just under 500 models that are available in NatureServe Explorer Pro, and that's only a fraction of the model library that's available. There are many more models that are currently undergoing review and revision and are ready for expert review, and some that are still in development. So our next step is really to facilitate the review of these models and get them to the publication status so they're more easily available to people. We aim to have a comprehensive library of models for imperiled species. For the Map of Biodiversity Importance, we were able to create models for within the conterminous United States, many of the imperiled species. These plots, though, show that we still have room to grow. So the donut plots show the percent of North American imperiled species that are globally ranked G1 or G2 that have habitat models in the library. So this includes species in Canada and the US. So we'd like to expand this library to get better coverage. One other consideration is that there are many partners who are creating models for certain taxonomic groups, and we don't want to duplicate efforts. So that is also where we'd like to focus effort in pointing to existing models that do a good job for some of these other species that aren't in the current library. We aim to improve and expand our multi-species data products, both through regular updates to the Map of Biodiversity Importance and by offering custom MoBI products. So custom MoBI, as Chris described, is where you could select a subset of species of interest, either filtering by taxonomy, conservation status, other statuses, and by certain geographies. We are also working to establish species habitat relationships for all species, and that will allow for custom MoBI products where you're looking at species that are associated with certain habitats. So for example, a goal is to be able to show the richness of imperiled species that are associated with temperate grassland or other habitat types. With MoBI updates, we've created the infrastructure for annual updates. The aim is to include all newly available and updated models for G1, G2, and ESA listed species. We aim to expand the taxonomic groups as they are comprehensively assessed, and to continue publishing any updates to the Living Atlas and the NatureServe Open Data Hub. Finally, we're expanding our modeling efforts to include climate envelope models. These are a type of species distribution model where you're specifically using known locations and climate predictors. So the objective is to define a climate envelope, which is a range of climate variables that align with the species observed distribution to project the potential distribution under current and/or future climate scenarios. And this helps to predict range shifts. The types of products that we're aiming to create look like this, where we are comparing predictions under the current conditions and future conditions. So these are two examples for two different species. What you're looking at is showing how current to future conditions will change and which areas will be suitable for the species based on the climate envelope. So in yellow, you see areas that are currently suitable for the species and will remain suitable under the warming scenario that's modeled here. And then in orange, you see areas that are areas for contraction where they're currently suitable, but they will not be suitable in the future scenario. And in blue, these are areas of expansion where those areas are not currently suitable, but they will become suitable in the future based on the climate. We see a lot of value in this information in how we can incorporate this information into decision support tools. This is a mock-up and just a small change on an existing tool we have. This tool allows Fish and Wildlife Service to go and look at an area and to see which species are known to occur in the area and which species have habitat in the area. So the current tool tells you the current situation. This mock-up is how we could then incorporate climate envelope modeling to allow people to make decisions in a climate-informed way. So you can see in the bottom right corner of the table that we have the area value for a species under current conditions. So this is answering the question of how important is this area for this species at this current time, as in how much of the habitat does this area encompass. So you can look at that under current conditions, and then if you're using and applying climate envelope modeling, you can project that forward under different warming scenarios. So how important will this area be after 2 degrees of warming or after 4 degrees of warming? And you can imagine that for different species, if they're shifting in different areas, that you could have some cases where an area is going to become less important for a species over time, and some cases where an area is actually going to start to become more important. And by using this information, you can make decisions that not only support the current conditions and current habitat for species, but that are likely to continue to support target species under different warming scenarios. And with that, I'm going to pass right back to Regan for our last application.
All right, thank you, Max. So I wanted to share, as Max said, just one more application of how we're thinking about using both the MoBI data set and those individual species models to inform conservation work. One of what I think is one of the more hardening trends in conservation in the past few years has been emerging corporate interest in quantifying biodiversity impacts and risks and progress towards sustainability goals. NatureServe has been giving a lot of thought to how we can take all these information products, we're generating them, and adapt them to meet some of those emerging corporate reporting needs, as well as other kind of conservation area-based reporting needs. We are currently in the process of scoping out a new biodiversity value site report product that would provide some baseline biodiversity information on species and ecosystems, as well as comparative metrics on biodiversity value for user-defined places, and also connect those organizations back to the natural heritage programs in our network who have even more information to offer to support kind of this area. Our hope, both with this and really all these kind of applications that Max has walked through, is to make it easy for the best available biodiversity data to be informing these applications, and to have these corporate efforts and other efforts backed by good science. If this is something that's of interest to you or your organization, we're in the early stages of this, so there's a real opportunity for us to figure out what the needs are here and how we could adapt some of these data products, and wanted to throw out that we'd love to speak to folks further as we develop some of these tools and applications. So that was all a giant whirlwind. We're almost at the top of the hour and want to spend just a minute kind of summarizing what we talked about, as well as pointing you to the specific places where you can access some of these information products. So the new release of the Map of Biodiversity Importance, it's available as data services that are on Esri's Living Atlas, as well as available through NatureServe's Open Data Hub. The QR code that's there will bring you directly to the part of our hub that has those 2024 layers. You can view them in an online map interface. You can go into the metadata, get a link that will allow you to directly download them to use in your own GIS. For information on the habitat models that feed that map, as well as all those other models in NatureServe's library, as Max walked you through, we have this great new species habitat modeling dashboard that's publicly available and ready for you to explore. I know we put a link in the chat, and I think somebody said they might have been having trouble with that link, so we will make sure that you have the right link so that you can get into that. All these links are going to be sent out with a follow-up and with the recording of the webinar, so you'll be able to get in and look at that. The dashboard will let you know what we have available. To see the models themselves, as well as the other NatureServe network data on species occurrences, as we said, NatureServe Explorer Pro is really the tool that allows that. As Max walks through, Explorer Pro works in two ways. It provides public access to our data at a resolution that our network data providers have set that they're comfortable with. And then Pro can also provide licensed access to that more precise data for those who need that. Right now in Pro, just in summary, the public is able to see what's currently pretty coarse versions of the habitat models for about 500 species. In coming weeks, we're going to be increasing the resolution of what's available to the public. So come back, it's going to differ state by state, but you should have finer scale data available to you for those models. We're going to be adding models for more species that are in our backlog. We'll also be working, as Max said, to add models into that reporting of what's at a site in that place-based biodiversity report. If you really need access to the precise data, including both things that are published to Pro as well as other things that are in other stages of development in the model library, the best thing to do is to submit a request for precise data access. The link that's here will direct you to a form to do so. We will follow up with you from there. There are fees for data access for those precise models. Those fees cover our costs for maintaining and expanding upon the library. We are streamlining processes to make it easier to get that information, directly into people's hands. If there's a ton of interest following this webinar, we'll have some work to do, but please reach out through that form. Let us know what you're interested in and we can follow up. We touched on a number of other things. The model review process, if you're interested in participating in that, we'd love to hear from you. The climate niche models, those custom MoBI products, is there a MoBI we could develop for a set of species or for a geography to inform a state wildlife action plan? These corporate products or other applications of the data. If any of that is of interest to you, we'll have our emails up on the last slide. We'd love to speak with you further. I mentioned our open data hub on the last slide as a place to access the MoBI layers. I wanted to point out that in general, this is a great starting point for accessing a variety of the spatial data offerings, including those beyond what we've discussed today. Go check it out. You could also visit the access data page of our website for many of the links we talked about and to get your hands on this, because we're here to provide good information for all of you to use. The last thing I want to end with is really just to take this opportunity to encourage you all to consider directly supporting the work we do to get these information products out into the world. As a nonprofit, it can be hard for us to keep up with the need. Max spoke earlier about that backlog of species with models that we're working to publish. 2 of those are shown on this slide. Donations to NatureServe will help us work through that backlog. They help us get more information into the public domain. They allow us to keep up with the science on taxonomy and status, do those annual MoBI updates. Support for us will allow us to keep working with our network partners to keep information flowing and allow us to improve the technology platforms that enable us to deliver all this information to you. speaking a little candidly and personally, we're at a pretty critical juncture for science in this country and for biodiversity. We're in a period when the rate of species extinction is skyrocketing. And some of those protections for biodiversity and those investments in the data that's necessary for effective management really feels to be a bit at risk. For 50 years, NatureServe as an organization has been working outside of federal government as a convening body for a set of state conservation partners to provide this high quality multi-jurisdictional data to serve business, to serve conservation organizations, to serve government land managers. And any support you can provide is going to go a long way in helping us to keep doing that good work in a pretty critical time. If you do want to donate to NatureServe, next slide, here's how to do so. Holidays are coming up. We have a great Adopt a Species program. 2 of those species in our backlog that we just talked about are available for adoption. If you have a brother who's a fly fisherman or your grandma loves orchids, it's the perfect gift. And a bit more seriously, you know, that support is what's going to allow us to protect the kind of beauty and wonder of the life that surrounds and supports us all. That's what motivates me. That's what motivates all of NatureServe to be providing this information, because we firmly believe it's how good conservation happens. And so with that, I want to thank you all for joining us today. If you want to hear more about what we have coming out, what data products we have available, webinars like this, please follow us on whatever social media platform you're into. We're out there. We're really eager to keep doing the good work of conserving U.S. species and ecosystems with all of you, and Canadian for the Canadians on the call. So with that, I think we can turn it over to question and answer. We have been trying to answer many questions in the chat as we've gone along. I'm sure not all of those are fully answered, but Chris, I've jotted down a couple notes on things we might want to touch on, but is there anything you see coming in that you want to read out that we could start addressing?
Let's start with the ones that you have.
All right, so I saw some questions somewhere about our kind of the review process and how we go about thresholding models and commenting on their confidence. I'm kind of combining a couple questions here, but Max or Chris, do you want to speak to that? I can read the more specific questions too. We had one from Bob Gottfried asking about how we set the thresholds. Are they statistically defined? If they're based on reviewer input, how does that get documented? And there was another question or comment somewhere about kind of model confidence and how do we know what makes a good model?
Yes. Yeah, I can take the question about the thresholds to determine the high, medium, and low probability habitat areas. So there is a default way that we define that statistically, and it's based on the ratio of, you know, false positives, false negatives, true positives, true negatives. So they're statistically defined initially. Then our expert review process, the first thing we ask experts to weigh in on is how those thresholds are set and whether they should be adjusted. So each of those categories goes along with the qualitative definition of qualitatively what does high probability habitat mean. So we have experts review whether the map they're seeing matches their understanding of the species on the ground. That information is captured in our model outputs review tool. So they set those thresholds. The reviewer thresholds that are set go into our database, and then we revise the model output based on reviewer feedback. You will know if those revisions have happened because in that metadata document that is always linked right closely with each model, at the bottom, there is a revision and review history for the model. So you'll see if thresholds were set and what comments reviewers made, and then also what revisions were made in response to those reviews. So there's the history available there, and we are working to get that metadata linked through the dashboard as well. So you wouldn't even have to go through Explorer Pro to get to that metadata document. It will be right in the dashboard, and that will be coming soon. And then Regan, can you remind me the second part of that?
Sorry, I was reading other questions, so I didn't quite hear everything you answered. I did say something about model confidence.
Confidence, yes. Model confidence is calculated based on 3 factors. It's both the model statistics, so how well the model is performing from a statistical standpoint. There's an evaluation of the methodology that's used, the data inputs and the methods employed, and then the expert review is also factored into model confidence. This is all calculated in a very explicit way using a rubric, and that rubric is in the NatureServe network model habitat model standard. So we have a standard that is available, and it just has a rubric that tells you exactly how to calculate model confidence, and then a draft of how confidence would correspond with different uses. That standard is currently, we're about to kind of check in with people doing modeling and using models to see what revisions need to happen there, but it's clearly documented. So the idea is that other people could employ the same standard. So folks creating models outside of NatureServe can also apply that standard, and we can compare apples to apples in that way.
Thank you, Max. There's just so many questions to go through. I'm trying to figure out what to pull up. There was a question about the environmental inputs that we might be able to expand upon. Sorry, I'm trying to find that in the long list. Oh nope, that's not it.
Was this one about the structural?
Yes, thank you, Chris.
Right. I can't find the question in the list either, but there was a question about what types of environmental predictors we use for modeling, and that was whether we use structural and composition factors. And short answer is we do have a lot of landscape configuration data for different forest and other land cover types. And we're beginning to explore some more structural attributes like canopy height and canopy density, things like that.
Thanks, Chris. We have just a few more minutes. I might end with, we got a couple questions about the climate modeling. Maybe I'll put a combined version out there. There's a question from Haley Hamilton about what we are using for our current climate across what time slice, and what data time slice are we using for future. And then there was another question about integrating some of the other environmental variables into the climate predictions. I can see if I can pull that up while you talk, Max.
Yes. The framework that we are thinking of using for the climate envelope modeling is to, instead of looking at time periods, to look at warming levels. So the idea is to use multiple global climate models so that because they're each different, they each have different assumptions. So we would look at what like a warming change would be, so +4 degrees, and then see what each of the different global climate models would have projected. And those maps would actually be showing what the greatest agreement between multiple climate models would be. So what that means is that the scenario that would be modeled would be a warming level that would actually correspond with a range of years in the future based on which climate model you're looking at, because the rate of warming differs by climate model. So that's how we're currently thinking of it, is to do warming scenarios, which again corresponds with that range of dates. And then the climate envelope models are really based on climate variables as the predictor variables. One way we've discussed, and we're early on in thinking this through, but we've discussed possibly masking the output. So with the climate envelope, it's going to tell you where you have areas that are in appropriate climate, but you can then apply masks of potentially, for example, land use, and there are actually models that show what future land use might look like. So we are thinking about incorporating some of those other variables that get more towards realized niche as opposed to fundamental niche via some masking protocols.
Well, that brings us to the top of the hour. I really appreciate everyone's engagement. I think we managed to get to most of the questions, but as I said, I don't actually know if all our emails are on the contact page online. I don't know if I pulled up that slide or not, but we would love to hear from you, and we will be sending out a follow-up that has many of the links of recording of the webinar as well. So we look forward to being in greater touch and hope you can use some of this information in your work. Thank you, everyone.